So you see that, and you have seen that since a few years, it's the rise of the machine. For me, that was Terminator 3. I think it was 1988, and I was amazed by this movie because they were the first 3D image, animated images that I was seeing, and I was like, wow, this is a blast. I love that. I started then robotics in 2019, the 30th of March, so it's 3 years now, and this was this weekend, actually, interesting. And I want to say that it was like my first try with computer-assisted surgery, and I kind of jumped back into computer-assisted surgery after a few years of frustration. And I was like, okay, let's do that. Let's go back to computer-assisted surgery, because I started in 2001, 2002 with Jean-Noël Argenson, my mentor in Marseille. And we were using at that time the Star Wars vessels that we were implanting in the knee to get the distal femoral axis and the proximal tibia. The sagittal cut was not that great, but we were super happy. And you see, it was made in France. We were very proud of that. And we were doing the first kind of computer-assisted surgery at that time. The 14th of May, which is my birthday, I visited for the first time Martin Roche in Florida, who is one of the developer of the Mako before it has been bought by Stryker. And I saw for the first time a Makoplasty, a unicompartmental knee arthroplasty done with a Mako. And I was like, wow, this is a blast. I really loved it. And I came back to Marseille. I said, Jean-Noël, we need to get that. I said, yeah, but it's very expensive, Seb. Okay, we can't afford that. You know, it's America, it's different, you know, and their implants are not that good, you know. So, and then I never got the Mako. So we kept on working. We worked on the smart tools. That was the time of PSI. That was the time of the accelerometer. So we went through all these phases of computer-assisted surgery where we reduced the size of the machine. We had smarter tools, more affordable, because there was no cost efficiency, no cost investment, no capital investment, and we worked a lot on that. During all these years, we published many papers, and all these studies were based on comparing patient done with navigation, accelerometers, PSI, chasing for the neutral alignment, and comparing the two systems to chase neutral and mechanical alignment. And that was the basic purpose, or the basic hypothesis, that bringing back everybody under the same bell curve will increase the survivorship and make the results of total knee arthroplasty better. But during all these years, the only thing that we were able to prove is that there was no difference between the computer-assisted group, whether for total hip, for accelerometer, for PSI, for anything, no difference. We even got a Knee Society award to say that. Can you imagine? So I was like, wow, it's nice, but I was surprised in a way, you know, but a little bit frustrated. And we were also at that time able to show that the bringing back everybody on the same bell curve is not increasing the survivorship. And we work on this famous study, or infamous study, with Mark Pagnano, and Matt Abdel, my friend Matt Abdel, published the 20 years result. So we know now that bringing back everybody under the same bell curve doesn't improve results. It's not enough. Doesn't mean that the alignment doesn't matter. It does matter a lot. The question is which one? And that's why after all these studies, if you read the conclusion of all these studies, they all saying that conventional instrumentation remains the gold standard, because we can't prove the superiority of robotics, of computer-assisted surgery, of PSI, of all these technologies. Doesn't mean that these technologies are not good. It means that we don't really know what to do with it, or how to use it properly to show a benefit for our patient. Because at the end of the day, this is the thing. So in every meeting, you have the against robotic or against technology that are saying, you know what, it's the Scott parabola. You know the Scott parabola, it's when there's a nice idea, it's a promising idea, and then everybody is using it progressively. It's becoming the standard of care, and then it's fading away. So we looked at that, and we did a publication, or we did a study to show that actually the Scott parabola doesn't apply for assistive technologies in knee arthroplasties. Instead, if you look at the numbers of publication, the numbers of use based on the registries, everything is growing up. And if you let me know, and if you say it's going to disappear, I'm going to say, yeah, maybe the big machine, the big arm are going to change, but assistive technologies are here and they are in our life. They are everywhere. So it's here to stay. How? We still don't know. And turns out that there's also new alignment options. And we published a lot about personalized alignment, the different concept. So you're going to tell me, Seb, there's so many definitions, I'm completely lost. And we have had 4 speakers this morning. None of them had the same agreement on alignment. And we're talking about people that are doing knee surgeries. And the last speaker couldn't tell us exactly what is his own personalized alignment. You know what I mean? So it's very confusing for everybody, but it's the revolution of how we see knee arthroplasty. I'm going to say it's an evolution. And the danger of that is to shift the curve. If you aim a target, center of the room, okay? If you are a little bit on the left, it's okay. If you are a little bit on the right, it's okay. But if you aim for a target on the left side of the room, there's a high risk to get the first wall. You know what I mean? So in knee arthroplasties, this is the danger. If you shift your curve without any assistive technology, saying I want to do personalized alignment, sometimes it's a little bit too personalized. And it's probably not what is good for the patient. So all these assistive technologies are tools, okay? They are just a tool. And remember, the goal is to reach a targeted angle, an amount of resection, or to optimize the ligament balance. And it's all about the combination of accuracy and precision. This is the goal of robots. It's not to make patient doing better. It's thinking that aiming for a target with precision and accuracy, which is the good target for the patient, and we'll come back on that, will help us to achieve better results. So this is what we can kind of come up after 20 years of using computer-assisted surgeries. So now what about the fact about robotics? So the first fact is that, as we saw before, we are not equal surgeons. There's good surgeons, there's not as good surgeons, and there's very good surgeons. And this is coming from the registries. And we know now there's outliers, there's a lot of numbers, and we know that there's surgeons with 5 to 10 times higher rate of revision than the others. Something is wrong. I'm sorry, but something is wrong. So we are not always good. And that's why the idea is to do a better job for every patient every day with a good accuracy, a good repeatability. And Atul Gawande published that very well in this book, Better. And it's very interesting to see that it's all about surgical performance. And we have to be good. We are athletes. We don't get as much money as the IPL league player, as we were talking this morning with Ashok, but we are still athletes. Doing 10 knees a day, 10 total knee arthroplasty a day, it's tough, you know, and the last knee, you're not as good as the first one. And we are not all as Ashok or Bob. We don't have that in our hands where it's all connected because of what we call experience and extremely developed experience. And it's not coming from nothing. They were not born with that. They developed this kind of skill by spending hours and hours and hours in the operative room. And I don't think that there's anything that can replace that. Never forget that. And robotic is just a nice tool that can help. That can help what? That can help to achieve a better target. Once again, it's just a tool that is more accurate than the other one. It may translate into better clinical result. I say may because you saw in the literature that there's very divergent publication. Most of the publication are made by the developers of the robot. And for Mako, it's absolutely true. I'm sorry, but it's very, very true for Mako, for example, and for the others, it's coming as well. So we can't really push into literature. It may translate. I do agree that it's relatively easy to learn. Why? Because you have somebody doing the planning in the room, you press on the burr, and for some of the system, it's relatively easy to learn. The robotic technique itself, it's not very complicated. But the problem is that the surgical technique and the surgical experience, it's not coming with the package of the robot. It's not something like you get a shoot, you drink something, and suddenly you become the super surgeon because you have a robot in your room. But there's another fact, which is that it can be efficient. It can be inefficient to reduce the ancillaries, to reduce the trays, and to stream down the instrumentation, which is making the life of the whole entire team easier because they don't have to carry as many tools as before. And there's another fact, the fact number 5, which is probably the most important of all this talk. The Wall Street is ready. Everybody is behind robotics because the robotic market is crazy. And it's crazy in every domain. And as healthcare is also a crazy domain in terms of business, robotics plus healthcare, there's a huge push. Plus, we know that it's all industry driven. And we know that we are all boys, maybe sometimes a little bit more than boys. And the only difference between a boy and a man is the price of the toys. And you see that we all pick that up, you know, and you can choose depending on the color and the car that you like. It's very industry driven. Plus, there's you don't have to, I mean, don't forget that there's negatives, you know, it's something that we have to consider as well. Because there's still cumbersome things, rigid bodies, the screen, you have to operate like that. You don't even look at the, you told me that. I don't even look at the knee. I look at the screen, you know. You told me that yesterday. So, I mean, it's okay, but there's bulky, expensive machines, and I do the same when I do robotics. The planning is still a problem, the cost, of course, and we're going to come back on that. And there's also another fact that is very important. Never forget the Dunning-Kruger effect. Okay, it's the graph between confidence and competence. And the danger of the surgeon with a robot is that. And this is the worst surgeon ever. The overconfident surgeon without the competence. And you don't buy the competence buying a robot. Okay, it can boost your confidence, but you don't buy the competence by buying a robot. So be very careful with that. Okay. The goal when you have a robot is to be here, to be confident and super competent, maybe even better than the average when you are not Ashok or Vaibhav. You know what I mean? So this is something that you have to think about. So remember that the real problem might be the surgeon, okay? And it's not because you give this guy a robot that is going to do a great knee. So it's not done by him. But you see, this is a robotic prosthesis. Okay, done in a very famous hospital in London for a bomb, and the patient from Oman came and I did the other knee, okay? And she's very happy with this one. She's not that happy with this one, but you see that the surgeon did a great placement of the implant, but he forgot to remove the osteophyte, which means that the tibial plateau is not sitting at the right place, which means that 2 years after surgery, there's already a radiolucency. So, and it's a robotic, this is a robotic surgery. You know what I mean? So don't forget to be a surgeon when you're using a robot. So where are we heading? So the super optimistic vision is, of course, to be the cyber surgeon and the cyber league of total knee arthroplasty. You place your picture here. You don't have to do anything anymore. You can cut with the tip of your finger. There's no arm. There's nothing. But it's not that true. And I was a bit tired when I finished my talk. So I said, okay, I'm going to ask ChatGPT. It's very trendy to do that. What is the future of robotics? And it turns out that the future of robotics looks promising. So I said, okay, it's worth to continue this talk and to try to think, how is it promising? Because ChatGPT doesn't give you much, actually. Just a few words. You can say that in a dinner. It's nice, but not with orthopedic surgeons. So I went a little bit harder. And one of my first things is that hardware. Hardware is terrible. It's hardware from the 2005, 2006. And when we started in Marseille, you remember I told you it's the Star Wars things, it's still the same. Didn't change in 20 years. While our phones changed a lot. Why don't we have the iBone, okay? A face recognition on my iPhone. Why can't we have that in the OR for our bones? That would be much faster, much easier, and probably much more accurate. The screen and connectivity, why can't we see through? I mean, our kids are playing VR all day long, and we can't do that in the OR. Why not? And it's coming, but it's still not there. You see, this is the latest baby. It's not even FDA approved. It's Think Medical. They came up with the idea of one of the latest out there, which is the latest robot where you just pin, and there's no arm, nothing. Is that the trend for the hardware? I don't know, maybe. But it doesn't really matter, actually. Because the real problem is not about the hardware. To me, the real problem of robotic is the software. Why? Because in total knee arthroplasty, we don't know where we're going. There's this famous quote from Saint-Exupéry, which is saying a goal without a plan is just a wish. In total knee arthroplasty, I wish I could have a goal to make my plan. Because today it's still complicated. I mean, we take everybody in the room. Nobody will dial the same thing in the computer. And we still don't know what is the best thing. Plus, we have a million combination. When you look at a screen on the computer, there's a million combination because there's so many numbers and how to do that. And you see, we did a study in Europe about the users of ROSA. It's the most important amount of time spent in the OR. This is with Franco Benazzo, the actual president of the European Knee Society. He came to visit me for ROSA. And we were talking, and my staff said, Doc, we have to move on, you know. I mean, you're talking on the screen, but we have to finish the surgery. And it was funny because yesterday I was in the OR and I saw this time as well. You see, there was the 6-hand planning. And it's funny because everybody, you see, it's nice, huh? So I was like, okay, I'm not the only one when I'm using the robot to play with the planning. So there's really something that we can do for that. But the problem is, what is the ideal target? We don't know. Okay, we don't know yet. We have no idea of what is the ideal target for the tibial cut, the distal femoral cut. And guys, insanity is doing the same thing over and over again and expecting different results. It's from Albert Einstein, and he was smart. And the thing is that if we do the same thing that we did with navigation, PSI, accelerometer, I mean, we can't expect any difference. We won't be able to show anything. So to me, the idea is to go towards advanced surgery where heart meets science. It's the trend of the future world. It's the museum in Singapore that my kids love. And to me, it's really the combination of both. The concept is to find the best equation between planning, implant, and effector. Effector is whatever it's going to be. How, whatever it's going to look, we don't care. If it's a big arm, small arm, pins, no pins, burr, no burr, we don't care about that. The real problem is to use technology, which had an incredibly fast evolution in the last 20 years, to empower our surgical excellence, which still takes 20 years to acquire. So this is why you have to be a good surgeon with a good tool to start an endless 4-step process, understand the 3D modelization of what we're doing preoperatively, apply, collect, and adjust. This is how we're going to become from the surgeon before. I will save the world with my knife. I'm the Superman in the OR. There's only 2 techniques in surgery, the bad one done by the others and mine. We all know that very well. Right? It's a classic quote. To tomorrow, where we are going to have data, where it's going to be data before, data during, data after, data all the time. It's going to take time. It's going to take a lot of time. I don't know if we will ever see that really, but I think that it's coming and we have to kind of take the train and jump in this train, because that's going to be the only way to answer the simple equation. We saw outpatient, okay, which means patient wanted to be better, faster, and forever. That's what they want. While the hospital wanted to be cheaper, okay? And we are in between, stuck in between, the patient pushing on one side, the hospital pushing on the other side. So we have to become smarter. Otherwise, we won't do this job for a long time. And we have to preserve ourselves to be able to have an access for everybody. And how we're going to get there? By applying the principle of value-based healthcare delivery, which is to understand that the value is coming from the healthcare's outcomes that matters for the patient, divided by the cost to deliver these outcomes. And as surgeons, we are not good to do that. So the hospital are pushing us on one side, the industry is pushing us on the other side, and we're like in between, not really able to do anything with that. So in conclusion, robotics and assistive technologies are here to stay. We are working on positive evolution in terms of hardware. There's still a lot to do. We don't know how it's going to look, but it doesn't really matter. The most important to me is to work on what we're going to do with it and how we're going to apply these plannings, this understanding of the knee anatomy to do a better job and to finally be able to answer or improve the answer to the value-based healthcare equation to make these technologies affordable and cost efficient. Thank you very much for your attention.